Hi, in today's mailbag video we have this 24 MHz dual channel arbitrary waveform DDS signal generator. This was kindly provided free of charge by Banggood.com, and they asked me to pick a couple of items which I wanted to review on my channel, and obviously one of those was that LED clock. And this is another item which I found quite interesting. So I do actually have an arbitrary waveform generator in my lab, but it's not a DDS generator, it's a true arbitrary waveform generator. So, it actually has a waveform memory. So every time you want to create a waveform, it downloads all of that into memory and then plays it back from memory. So if you want to tweak things on the fly, it actually takes a moment or two to change the waveform because it has to write to RAM before it can start reading it off again. So I was looking for something low cost which some of my viewers, some of you guys might be interested in, and something around the £50 price point is not too expensive, and especially if it performs reasonably well. I know that you can get kits on eBay, but they're kind of bare board modules, whereas this is actually mounted within a case. So I thought this one would be quite interesting. So let's have a look inside the box. I've not actually had a look at this, so here we go. Right, so we've got a mains lead here. This is a Chinese lead. I won't be using that. It looks like we've just got a figure of 8 connector on the back of the unit, so yeah, I don't need that. We've got a USB cable, so obviously as this is an arbitrary waveform generator, you can download waveforms onto this device. So I don't know if we'll look at the software in this video. I might do another follow-up video looking at the software after I've had a little play with it, because it might take a while to get that working. I don't know, sometimes the drivers are a bit of an issue. And then just inside the box we've got a couple of test leads. So these have got BNC connectors and then crocodile clips on the other end. Those are reasonably good quality. We've got a couple of batteries, that's a bit random. And then we have the device itself. So I'll just reposition the camera and we'll have a look at the unit. Right, so here we have the unit on the bench. It's reasonably compact, so about 200mm wide or 8 inches, and it doesn't go back very far, probably about the same dimension. And it's in a kind of the kind of box that you probably find at Farnell, so a kind of project box. It's got a little tilting bail to have it upright if you're using it on the bench, or obviously you can fold this flat if you have it on a shelf or something like that. On the back we've got a couple of BNC connectors. I think these are triggers. We've got the USB connector, and then we've got the mains input at the back here. And then on the front we've got a power switch, we've got the LCD, it looks like a 2x16 or something like that. We've got some tactile switches here, we've got a rotary encoder, and then we've got the 2 output BNC connectors here. There's also another BNC connector here, so it looks like this can be used as a frequency counter as well. So it does have a count button here, so we'll have to have a look at the operation of this when we turn it on. But before we turn it on, obviously we're going to have a look inside and see what's inside this thing. So what I'm expecting is that we'll probably see that actually most of the electronics is probably just going to be on the front panel. So we'll probably just see an FPGA, maybe a DAC, something like that. Probably some interfacing logic for the counter and the 2 inputs at the back, and then probably we'll see a switch mode power supply. It's not heavy enough to have a linear power supply in there, so that might be something which I might modify in the future, but I expect this is fairly empty actually. So it looks like there's just 4 screws on the bottom and then a couple of clips to get the front panel off. And it looks like these are actually kind of wood screws, they're not even self-tapping screws. So as expected, there's not a great deal inside the box. Most of the electronics looks to be on the front panel. So what we've got in the actual casework here is the USB interface at the back here. There's just 3 thin wires here. Yeah, so this must be a USB to serial converter. I can see the markings on the PCB say TX, RX and ground. So this must just have a USB to serial converter. We've got the mains inlet at the back with some fairly thin looking wires here going onto the board and then back off again to the switch at the front panel. And then we've got the power supply here, which doesn't look too bad actually. to be expected for this kind of unit. We've just got a fairly simple device here. So we've got the bridge rectifier from some discrete diodes on the left. We've got a common mode choke for a bit of filtering here and a glass fuse. We've got the bulk capacitors and an unknown 8-pin switcher chip. The top's been scrubbed off, it looks like. And then we've got the small flyback transformer. So the current requirements for this device is probably quite low, hence the very small size transformer here. And then we've got a number of wires coming off this board to the front panel. So given the type of device this is, I imagine there'll be a plus or minus 15 or plus or minus 18 volt supply for the op amps and that kind of thing on the front panel. And then maybe a logic supply, so 5 volts or 3.3 volts. And that's about all there is really. It's obviously got the feedback and everything. You need a reasonably stable power supply for something like this. It doesn't actually say what the supply voltages are. Oh yeah, there's a couple of markings here on the front panel board. Yeah, so 5 volts, minus 12 and plus 12 volts, and ground. So let me just set up the camera again and we'll have a look at the front panel. Right, so here we have the front panel PCB. So we'll just quickly work our way from right to left. So we've got the power supply connector here. This is the input from the switch mode power supply. We've got a couple of bulk capacitors here, and then some linear regulators. So because we've got the FPGA on here, we've got the 3.3 volt regulator and a 1.5 volt regulator. We've also got a 79L05, so that's possibly for all of these analog switches on the left here for supplying the negative side of these. We've got some more bulk capacitors here, and then we've got the microcontroller. So we've got an STC microcontroller. This is a fairly common thing to see in a piece of Chinese equipment. These are low-cost microcontrollers and kind of reasonably similar to the PIC16 series in terms of their power. And then we've got underneath that some 7.4 LVC logic, which is taking the input from the TTL inputs at the back through some series resistors and then presumably clamping to the supply rails on here. And then this is probably just doing some logic level translation. And then just to the side of the microcontroller we've got the FPGA. So here we've got an Altera Cyclone, and that's what's doing all of the waveform generation. Next to that we've got a whole bunch of analog switches here. So these are 4053s, so 222 channel analog switches. I'm not 100% sure what they're doing with all of these really. I don't know if they're doing some multiplexing of some of the outputs from the FPGA. I'm not really too sure. But this obviously feeds in this direction into this dual op amp here. So we've got a Japan Radio Corp op amp here, and then finally 2 output devices under this heatsink for providing the outputs to the front panel BNC connectors. We've also got a little piezo buzzer. Curiously, it still has the sticker over it, but if this beeps every time you press a front panel button, we'll probably be grateful for this still having the sticker on there. And then just on this PCB with the USB connector, we've just got a CH3400, so this is a USB to serial chip, one of the types that they tend to fit on the Chinese Arduino clones. Right, so I'll just reassemble all of this. We'll have a quick look at the specifications and then we'll test it out. And if it does turn out to be a reasonably usable device, one thing I'm definitely going to do is remove this switch mode power supply and put in a linear supply. So if you recall from my videos about the USB charger, this doesn't have an earth connection, it's just got the 2-pole connection to the mains. And because we've got this suppression capacitor here bridging the primary and the secondary of this transformer, the whole device will float up to about somewhere between 90 and 100 volts, something like that. And even though the current's quite small, somewhere between 50 and 100 microamps, that could fry some equipment that we connect to it. Obviously, we saw it lighting up a neon screwdriver, so there's a reasonable amount of current there that could damage your piece of equipment that you're testing. So yeah, I think I will replace this with a linear transformer and power supply if this device does turn out to be quite good. Right, so let's have a quick look at the specifications here. So obviously this is a 24 MHz dual channel DDS function generator and counter. It says the output signal amplitude up to 20 volts peak to peak. We'll have to test that. I don't think that's right because obviously we saw the power supply only had a plus or minus 15 volt supply and there was no DC to DC on the front panel board. and then we can output sine, square, triangle, ramp, pulse, staircase and DC voltage waveforms, pulse wave, pulse width, so basically PWM can be adjustable, and that's something on my full-size TTI arbitrary waveform generator, which is a little bit annoying. So if you want to create a PWM waveform, you can do that, but if you want to quickly increase the duty cycle or the frequency, that's not something which you can just twiddle the knob and it happens immediately. It does have to quickly reload the waveform into RAM, and in a future video we will have a look inside that device because it needs the battery replacing. So we've got two channels here, completely independent. User-defined waveforms, obviously it's an arbitrary waveform generator, so we can download some waveforms into the 2048 by 12 bits memory here, which we can read up to 250 megasamples a second. Burst output, selectable manual trigger, so that's these inputs on the back, internal external trigger. I'm not quite sure what all of this means. Measurement functions, so we've got 100 megahertz frequency counter built in and pulse counter. I think that's about all we need to read on here. So let's plug in the device and see what happens. Right, so I've got a power lead connected, so let's turn it on. We've got revision 2 here. I don't know if that's of the firmware or the hardware, but we've got a fairly clear display on the front here, so it does indeed look like a 2x16 LCD. It's kind of got a yellow backlight rather than a green, and it's saying at the moment we're outputting a 10 kHz 10 volt sine wave. What we'll just quickly do is check the output voltage on those BNC connectors just to see if it is floating up at a high voltage. So I've got one end of the Fluke 289 plugged into ground, and then yeah, we're reading about 95 volts. Let's see how much current. And I think someone asked about this multimeter before, whether it retained the setting, and it does indeed retain the setting when you turn it off. So when you go back to current, it stays on the previous that you had it set to. So in this case AC. If you've previously been using it on DC, it does stay DC. Wow, so this one's really quite high. This is 500 microamps, that's half a milliamp. Is it really outputting that? That's very high. I'm not sure if it was overloading that range, but yeah, it's close to a milliamp. You're definitely going to feel that. Yeah, I wonder what kind of frequency that is. Let me just set up the oscilloscope. Right, so I've got the scope probe connected to the shield of that connector, and I'm not sure if you can see on the scope here, but it's showing 332 volts peak to peak at 50 Hz, so interestingly not at the switching frequency. And yeah, it's about, what's it saying here, 96 volts RMS. So that doesn't really feel too confidence inspiring, considering the meter was saying that we were seeing basically a milliamp there. I'm not sure if you can... Oh yeah, you can definitely feel that. That's a bit of a buzz. Yeah, that's not great. I think I'll plug it into the isolation transformer before we do any further tests. So that's, I don't know if that's a fault. We'll have to have a look back inside at the switch mode power supply and just check there's not something bridging that. That doesn't quite feel right. Right, so that's a lot safer. We've now got the isolation transformer on the signal generator, and you can see the voltage here is, you know, just down in the noise really, 20 volts peak to peak, but there's no current behind that, and obviously not earth reference, so I can touch this, and we're not getting anything at all, no change to the waveform. So now we can continue testing, and then after we've done that, we'll have another look inside and just see if there is something faulty with that power supply. Right, so I've not used this device before, and there was no instruction manual with it, so we'll just be having to play with the functions. The listing did imply that it needed a 50 ohm terminated connection, but we seem to only be getting 5 volts peak to peak from our 10 volt output, so I'll just remove the 50 ohm terminator and see if that changes anything. And yeah, there we go, we've got 10 volts peak to peak. So I'm not really sure why it implies that you need a 50 ohm terminator when it drops the signal voltage. But It looks like a fairly reasonable user interface at first glance. So there's a little underscore under the 0 here, and if we turn this, yeah, we do indeed see the frequency increase. We've got a couple of arrow buttons, so I assume that moves the cursor here. Yeah, there we go. So we can set some presumably quite low frequencies. I'm not sure what it goes down to. Yeah, and it is actually outputting that. You can see it slowly creeping up. And you can see where it's changed frequency. So this is the DDS in action. So every time you change the frequency, it restarts that waveform. But that muted buzzer isn't too bad, actually. It's not too intrusive, so I don't know if they purposely left that sticker on the buzzer so that it didn't annoy you every time you push the button. So how do we change the amplitude? So we've got a button here that says palm, which I assume is parameter. Yeah, so that scrolls down here to the amplitude here. And it can indeed output up to yeah, 20 volts peak to peak, and I was being a bit thick earlier, so obviously at plus or minus 15 volt supply, that will give us up to 30 volts peak to peak. Yeah, so I was being a bit dim there, but it does indeed go up to 20 volts peak to peak, and you can see the changes are nice and quick. The interface is definitely quite responsive, and the rotary encoder doesn't seem to skip or anything like that. That's not too bad at all. So the parameter button changes. We've also got the offset here, so we should be able to raise that up and down, which seems to work nicely. And then we've got the duty cycle. Obviously that doesn't really make sense on a sine wave. And the phase. So the phase doesn't make much sense when you just trigger from channel 1 onto channel 1 on the scope, but obviously if we were using the second channel, we could move them in and out of phase of each other through this, and then we're back up to the frequency. But that seems quite responsive. That's not too bad to start off with. Let's have a look what the wave button does. So here we can change the wave to square, triangle. We've got our arbitrary, so these are all our memories presumably. And there's also some presets, it looks like. That looks like just noise. That's kind of a cardiac, trapezoidal, and then we've got a sync, and then we've got some other waveforms here. That's more noise. So we've got quite a few waveforms here, and obviously now we've got the square wave, we can set the duty cycle, and yeah, that's quite nice actually. I can see that being quite useful on some projects where you just quickly want a PWM waveform, and that is one thing which is slightly annoying about the waveform generator that I've already got, so that doesn't seem too bad at all actually. One thing which is a bit of a gotcha for new players is obviously these waveform generators output the signal about 0 volts, so if you're interfacing with logic you do need to offset that signal. So let's see, we can move that up. We should be able to move it up here, and yeah, we can get it around, you know, so it's normally at 0 volts and then pulsing up. So yeah, we've got all our various waveforms. We've obviously got this button here which is the frequency counter, so let's see what happens if you push that. So we've got external frequency, 0 Hertz, function, external frequency. What else do we have here? Does this do anything? No, so we've just obviously got our input here. So we've got a 10 kilohertz frequency here. So if we feed this in, we should get 10 kilohertz on the display. And there we go. 10.001, that's not too bad. That's good enough for an indication. Obviously I've got my 12-digit frequency counters here disciplined off the GPS. But that's quite useful, just especially if you're just setting up your lab and you just have the money for a small instrument like this. That's quite useful. Then we've got another button here that says sweep, so let's see what that does. So we've got a linear sweep. How do we start it off? No, it's not a push button. Right, so I managed to find a manual on the EV blog forum for this device, so I'll put a link for the manual below. And it looks like this is indeed a push button rotary encoder. It didn't quite feel like it clicked or anything like that, but if you push it in a little bit further than I did, it actually starts the sweep. So you can see this is sweeping between 10 and 20 kilohertz, and that seems to work quite well. So that's quite a handy function, and obviously you can change that sweep range to any that the device allows. So that's quite a useful function. And then finally we've just got this sys button, and it looks like we've got some memory functions here. So we can save, it looks like 20 memory positions. So you can save your configurations so that if you're doing some testing, for example, you can, if you're writing a test plan, you can say, I want this device to be tested at 10 kilohertz at 3 volts, and you can say just go to memory position 1 for that, and then memory 2 for the second preset. So that's quite a handy function as well. You can just store your settings there. I don't think there's anything else really to show on here. In the next video, what we'll do is get the software working and see if we can load some arbitrary waveforms into it. But it does seem to work quite well. Let's have a look inside again, just at that switch mode power supply, to see if that is faulty or whether that's a design flaw or something like that, because I'm not terribly happy with that outputting close to 100 volts at 50 hertz. With a current of up to a milliamp there. That doesn't quite feel right, and that definitely would fry your little microcontroller if you had one of the pins grounded and then connected it to this. So let's have one more look inside here. Right, so just a quick look at the switch mode power supply board. Doesn't reveal any faults as such. We've got a good isolation gap here, well, good enough anyway. It's a little bit close here, but more than the 3 or 4 millimeters that you really want. There's a bit of a mark on here, but it looks like it's been scraped over here as well, so this possibly has hit the floor during production or something like that, I don't know. There's a bit of dodgy soldering on the suppression capacitor just here, but I won't get the macro lens out, but this EMI suppression capacitor here looks to have been fitted as a 10 nanofarad capacitor rather than something more sensible like 1 nanofarad or maybe half a nanofarad, something like that. So you'd normally see something about 1 nanofarad, and that would normally mean that you get about up to 100 microamps leakage through that. But obviously that order of magnitude out has also meant that the order of magnitude of current has increased. So that 1 milliamp is a little bit unacceptable, really. I don't know if that's a production error or whether they intended that, but it's not really going to help with any of the EMC issues. It's just making the device a little bit dangerous. So that's not really that good. I'm definitely going to change that for now just to something smaller. And then, as I said, I'm going to change the power supply anyway for a linear power supply, so we don't have any leakage current on the BNC connectors, because you don't really want that frying your device. So overall, this signal generator is really quite usable. It's let down by this power supply, and I'm going to correct this, but probably change it for a linear power supply in the future, because it is actually a nice piece of kit that's good enough to be on the bench here. It's really quite responsive. You turn the encoder and it's immediately changing the frequency or the amplitude. There's no lag at all between changing this and the output appearing. And the fact that it's got 2 channels that you can link in terms of phase is also quite nice, and also One of the functions in one of these buttons is allowing you to link the parameters, so you can link the amplitude or the frequency if you want to just quickly change one, the other can change if you've got a different waveform being shown. So it's really quite a usable signal generator. And on the Banggood website there's also some bare board modules. I'm not sure if it's the same module exactly, but if you didn't want the whole device as a case, there are definitely some arbitrary signal generators, and if they're of the same kind of user interface and everything, I'd definitely recommend that for a beginner's bench. So a big thank you to Banggood for sending this device to me. In the next video on this device we'll have a look at the software and how we can load some arbitrary waveforms onto it. We've got one more review video coming up, and then I've got some projects which I'd like to share with you. So I have got some technical content coming soon. It's not just going to be reviews, so do stick with me if you are not particularly interested in the reviews. But if you did enjoy this video, please give a thumbs up, comment down below. If you want to purchase this device, click on the link below. It is a referral link, but it does mean that I'm probably more likely to get some free equipment in the future to review and share with the channel. And it just means that we get to try out devices like this and see if they're any good, rather than allowing beginners to purchase this and find out it's completely suitable or unsuitable for their application. So a big thanks to everyone who comments down below. Subscribe if you haven't already, and thanks for watching.